The last thing we're going to talk about is how to use Desmos to solve quadratic word problems. Okay, so we're just going to do it with an example, because once you kind of see one, you can pretty much figure out how to do the rest of them. Okay, so in this example it says a goalie kicks a soccer ball with an upward velocity of 65 feet per second. So that's actually where this part comes from. The path of the ball, so I think that's supposed to be of, so the path of the ball can be modeled by that function. So that kind of represents, like if you graphed that, that would represent the path that the ball took in the air, which represents the height of the ball, h feet, so it's just representing the height with an h in the air after t seconds. So after so many seconds, it's looking at the height of the ball. Okay, so it's asking different questions. It says, how high does the ball go? When does it reach this height? So when it says when, it's talking about a time. How high is talking about how high in the air did it go. And it says, how high does the ball go? So that's talking about like maximum height. And then it says how long till the ball hits the ground. So how long does it take before the ball hits the ground? And then how high is the ball after 1 second? Okay, so whenever you're given a problem and Desmos is available, I would go ahead and type that in Desmos. So that's the first thing we're going to do. We're going to type that in Desmos. So you pull up the Desmos app, and then you would type that in. So you could type it in how it looks with the h of t and everything, or you could just type in that equation. It'll work the same. Just to show you how to type it in, you hit h parentheses t, and then you have to hit equals, and then you type in your equation. So it would be negative 16x squared, or they're using a t here, so I've got to make sure that my variables match. So it'd be t squared. So you can either hit the a squared button or the a to the b button, and if you hit the a to the b button, all that does is it makes it an exponent. Okay, but then you have to hit, then you have to arrow or click over so that it'll keep going and not be an exponent. Then you type in the rest, so it'd be plus 65. And notice it's kind of graphing it as you type it, but make sure that you don't look at the graph until you actually get the whole thing typed. Okay, so now there's my graph, but notice it's hard to see. So you can either kind of adjust it to where you can see, and so sometimes that works, but sometimes you have to kind of zoom in so much that it's really hard to see all your points. So something else you can do is you can click the little wrench on the side, and you can actually adjust. If you look, it says x-axis, you can adjust those numbers to kind of be to where you can see it. So like I might make it to where I could see maybe from like -5, oh, gotta erase my extra negative there, -5 to maybe 5, because it didn't look like my graph was very wide. And then my y-axis is how far you can see up and down. So this left number is how far down you can see. And so maybe I'll make it -5, and then how high I can see. Well, I'm already, like when I adjusted it, it was at 68. So maybe I'll go a little higher than that. And then I'm going to look at my graph. So after you type that in, you can look at your graph, and if it looks better, which mine definitely looks better, then I'm good. Okay, so just make sure that you can see all the key points. So your goal, remember, when something's being thrown in the air, so this is a soccer ball being thrown in the air, your goal is to see like where it crosses the y-axis, the maximum point, and then where it hits. And so for this problem, that's what you're looking for. And so notice I can see that now. Okay, and then to pull up your points, you just click on your equation, and notice all your points come up. Okay, so the first question says, how high does the ball go? Well, that would be the maximum. So if you look at your picture, that's that point right there. So I clicked on that point, and remember this coordinate, that first number, the x-axis is your time. So whenever I'm looking at it, so I'm going to just kind of sketch a graph of it over here. Okay, that max height, that first number is like the time, so I'm just going to round that to the nearest hundredth. And then that second number, oh, yep, there we go. That second number is the actual height. So we got 2.03, and then we have 67.0, and we'll round it to a 2 there, okay? So it says how high does it go? Well, your x value is the time, so that's like the seconds, and then this is the height, and it's saying that the height is in feet if you read the problem. So how high does it go? Well, it goes a height of 67.02 feet. That's the maximum that it goes because that's that top point. Then it also says in part B, when does it reach this height? So that would be this part. So it reaches that height after about 2.03 seconds. And then the other question says how long, so how long is a time till the ball hits the ground? Well, remember, it goes up, and then at that point, it's back down on the ground because remember, your y-axis is your height. And so at this point down here, that's when it's back on the ground because it's like 0 feet essentially above it. So you're actually looking for this point right here. So let me click on that. So that would be the time, because that's your x value, and then that's how high it is above the ground. So that would be the time you're looking for. So how long till the ball hits the ground? Well, it hits the ground after 4.08 seconds. I'm just going to round it to the nearest hundredth. So that's that point. Okay, and then the last one says, how high is the ball after 1 second? Well, 1 second, I think this is 1. Well, it kind of looks like it's at 50, but what if I'm not sure? Maybe my graph, when I adjusted it, it's kind of hard to see where that is. So you can look at your graph and try to see. So at 1, when the x value is 1, you're looking at where your graph is, which looks like it's at 50, or you can actually use your equation because remember, your t is the time in seconds. And so if you're looking at how high will the ball be after 1 second, you're really looking at when the t is equal to 1, what is the height? So you can actually take your equation and you could plug in a 1 for your t. So you could take negative 16 times 1 squared. So notice I'm plugging in a 1. And then plus 65 times 1 plus 1. So you could just take your equation and plug in the 1 because that's your x value. So you can take Desmos because you have it available. And then you can plug in a 1. And I accidentally made that not exponent anymore, so I'm going to have to change that. No biggie. So let me go back and put in the exponent. And then I'm going to change that t. Put parentheses, make sure you plug in parentheses there when you're plugging in. And now I do have to erase this part or it's going to think that's graphing it. And then notice it is 50. So when after 1 second of this person kicking the ball, it ends up being 50 feet, which is crazy, in the air. Okay, so how high is the ball after 1 second? Well, that ended up being 50 feet. So you would say it's 50 feet in the air. So there you go. So that is how you use Desmos to help solve these problems.